Hi everyone, welcome to my presentation about research on the performance limitations of visual-based perception system for autonomous vehicle under severe weather conditions. Our team is from Tongji University. I'll divide my presentation into 4 parts: introduction, method, experiment, and results. Conclusion. First part is introduction. Autonomous vehicles need to operate in highly complex, dynamic environments. In such case, while systems are free of fault, safety-critical problems may still occur due to performance limitations. That is, safety of the intended functionality problem. Visual-based perception system is widely used in autonomous vehicles. Severe weather conditions will reveal its performance limitations, and then that may cause accident under some conditions. Explorations of the influence of severe weather on visual-based perception system can be helpful to quantitatively evaluate the performance limitation of the system and set the operational design domain of the AVs reasonably. The working process of visual-based perception system can be divided into images obtained by camera and target identification by recognition algorithm, as is shown in the left figure. Existing research mainly focused on the impact of environmental conditions on the image obtaining process or directly on the targeted recognition result. So, there is a lack of research on the influence of the image quality on recognition results. Besides, as to the type of severe weather, researchers mainly focused on the influence that a specific weather condition with different intensity has on the perception system, and there is a lack of comparative research on different weather types in a same scenario. The second part is method. The overall structure of our method is shown as a figure below. We use a stage evaluation method to explore the influence mechanism of severe weather conditions on the quality of recognition results of the visual-based perception system. In stage 1, we carry out a comparative analysis of the influence of different severe weather conditions on the quality of obtained images. We consider rainfall, snowfall, high luminance, and fog, and conduct a research on their influence relationship between image quality evaluation metrics. In stage 2, we analyze the influence of images quality on the quality of recognition results of the perception algorithm. This part is carried out by building a model fitting image quality evaluation metrics and recognition results. We choose 5 indicators to contribute to the image quality evaluation metrics. They are peak signal to noise ratio, mean structural similarity, luminance, contrast, and channel entropy. The first 2 indicators are full reference indicators. They need a reference image. The latter 3 indicators are no reference indicator. They can be acquired directly. As to the second stage, the relationship between image quality and recognition results. We use 5 indicators introduced above to show the image quality, and choose classification confidence as analysis parameters of the recognition result. As to fitting model, we choose multiple linear regression model. Before model fitting, we have to ensure that the variables satisfy some preconditions, especially preconditions E. If it cannot be satisfied, the loss function should be modified, and the model should be changed to weighted multiple linear regression mode. The evaluation object of our method is visual-based perception system, including camera and recognition algorithm. So, the image obtaining stage of camera cannot be ignored. In our method, we adopted video dark box to carry out the research. The schematic diagram and the real product of the system are shown on the bottom of the page. To ensure the comprehensiveness of the research, we choose scenario simulation software IV2022 to generate scenarios, and it can cover all types of weather we need. And since the focal length of Mini IX1 is fixed, a comprehensive lens was added to reduce the focal length and get clear images. Part 3 is experiment and results. In our experiment, Mini IX1 was adopted as a system under test, and we took SSD algorithm as the recognition algorithm. We used simulation software to generate test scenarios. In the stage of image quality evaluation, only the intensity of a specific weather conditions can be changed at a time, such as rainfall and snowfall, while in the stage of target recognition result analysis, scenarios with a variety of severe weather conditions can be generated, such as night with rain and nights with rain and snow. The distribution of the image quality evaluation results for stage 2 are shown in the right figure. According to the results, different weathers make image evaluation metrics change differently. For MSIM, with the weather intensity increasing, the MSIM of snowfall and fog scenario basically remains stable, while the MSIM decreases in rain and high luminance scenarios. For luminance, several weather conditions except for rainfall will lead to the increase of the image luminance. As to contrast, rain and fog will lead to the reduction of contrast, while snowfall and high luminance conditions have the opposite impact. For target recognition stage, because there is no homogeneity of variance between the samples, we use weighted multiple linear regression mode to feed the parameters. The loss function is shown below. L represents luminance, that's the weight variable. According to the results of Pearson correlation analysis, we selected the 3 most relevant parameters for model fitting. The obtained regression mode is shown as this. After model fitting, BP neural network was introduced to analyze the importance of the evaluation indicators. According to the results, MSIM, luminance, and contrast have the relative greater impact on the classification confidence, which is consistent with the weighted multiple linear regression mode. We choose 2 scenarios, S1 and S2, to analyze the performance of the regression mode and the influence mechanism of different weather types. The scenario configuration and the classification confidence are shown in the table. In scenario S1, 90% luminous intensity, and S2, 90% fog intensity. The classification confidence, the variation of the predicted value, and the output from the recognition algorithm are 2% and 1% respectively. The classification confidence in 2 scenarios are both decreased, but different weather affect the classification confidence in a specific way. With the high luminance of the environment, the luminance of the obtained image in scenario S1 increases. The image luminance in scenario S2 also increases due to the high reflexivity of the water droplets. But the contrast of the images obtained in scenario S1 and S2 changes with different trend. The contrast value increases in scenario S1 because there is more light reflected from the target. However, the contrast value the contrast value decreases in scenarios 2, with more light reflected from water droplets. Part 4 is conclusion. We propose a method to analyze the influence relationship and the mechanism between severe weather condition and recognition results. In stage 1, a set of metrics were adopted to evaluate the quality of image obtained by camera, and the image quality obtained under different weather conditions was evaluated with monofactor analysis method comprehensively. In stage 2, recognition result was fitted with image evaluation result to explore the relationship between image quality and target recognition with confidence, and the performance of the model was then analyzed. Based on the results, the image quality can be used to infer the influence of environment on the target classification confidence, and then the possible performance limitation under severe weather conditions can be identified. The research results can also be a reference for the test and optimization of the perception system, so as to set the ODD more reasonably and improve the safety of the AVs. That's all about my presentations. Thanks for your attention.